How do Beachmarks tell you why things break? Have you ever wondered how engineers figure out why materials fail? One fascinating clue they look for is called Beachmarks. These are crescent-shaped patterns found on the surface of a material that has failed due to fatigue. Imagine the marks left by the tide on a beach. Beachmarks look similar but tell a different story. When a material experiences repeated stress, cracks can start to form. Beachmarks appear as a series of concentric rings or nested curves. Each mark represents a moment in time when a crack advanced, paused, or slowed down. This happens under cyclic loading, which means the material is subjected to changing forces. By examining beachmarks, investigators can piece together the history of a crack's growth. Each beachmark corresponds to a period of crack advancement, followed by a pause. This pause can be caused by changes in load or environmental conditions. For example, if the spacing between beachmarks is wider, it indicates that the crack grew faster during that time. Conversely, closer spacing suggests slower crack growth. The orientation of beachmarks is also important. They are always perpendicular to the direction of the applied stress. This gives clues about how the material was loaded. For instance, if the beachmarks are oriented in a certain way, it might indicate whether the material was under bending or tension. Beachmarks are different from microscopic fatigue striations. Striations are fine lines that show individual crack growth cycles and requiring high magnification to see. Beachmarks, on the other hand, can often be seen with the naked eye or low magnification. They serve as arrest marks where crack growth temporarily stopped, making them useful for reconstructing the sequence of events leading to failure. In practical failure analysis, identifying beachmarks helps engineers understand how and why a crack developed over time. This knowledge can guide improvements in design, material selection, and maintenance practices. If beachmarks indicate that crack growth was influenced by fluctuating loads or environmental factors, engineers can take steps to control those conditions or strengthen the component. Overall, beachmarks act like a natural record on the fracture surface. They tell the story of fatigue failure and provide information about the stresses and interruptions that cause the material to break. This makes them a key tool in fractography, which is the study of fracture surfaces, within failure analysis methodologies aimed at uncovering the causes behind mechanical breakdowns.